Hi, everyone. Thank you for joining my talk, Stranger Danger, Finding Security Vulnerabilities Before They Find You. My name is Liran, and I'm from Sneak, where we build developer-friendly security tools to help developers fix issues in projects they're building with open source. I'm also actively involved in the Node Security Working Group as triaging vulnerabilities and helping find and bring this awareness to developers, as well as other related security activities like the OS projects and basically being an activist around web application security. I'm happy to join you today and talk about how awesome open source is. We're all using it in one way or another. Some of us are maintainers, some of us are consumers, some of us just contribute one-offs or maybe regularly to open source projects, and this is great. We have open source as basic building blocks for us to build software. And today, nobody would probably question the fact that open source has made an incredible, significant impact on modern software development and continues to expand every year. 1.4 million packages on NPM kind of vet this story for us. Actually, today, maybe 1.5 million already. So this is growing, year after year, and we're seeing it across ecosystems. It is even growing, open source new packages getting added to the registry while we are installing open source packages. It's incredible. But really, how much do we know about open source packages, about the dependencies that we use, about the maintainers who actually use them and do anything from basically security testing, or do they not do security testing? What about the maintainers that add dependencies? Do we test those those packages and all of those things that stem from it? So as you can imagine, there's a lot that we may or may not know in open source dependencies, and that's what I want to talk to you about today, about this software supply chain security ecosystem where we are part of. In fact, there's really an interesting article just coming off on October 2020. This is when this was published, a paper by basically the Cyberspace Solarium Commission that was talking about this exact problem, about the fact that it calls for a center for open source software security to test vulnerabilities in open source software repositories, which serve as the foundation for most of today's software. And this is an acknowledgement that was officially and formally greeted in this paper, basically acknowledging the fact that we're all dependent on open source. This is an entire supply chain issue, and we're all impacted by it. So we should do something about it. We should raise the awareness and treat it with the exact risks and concerns that we should. So moving on with this to another research paper, which has actually pointed out an interesting fact. It found that for every average npm install you are doing, you'd be pulling in more than 4 levels deep of dependencies. So this is actually just showing us how much we are dependent on open source software, in some ecosystems more than others. That same research paper had actually pointed out other highlights. This other one is that they found that 61% of all of npm packages could be considered abandoned. Now, what exactly does abandoned packages mean? I have no idea, but what we're learning from this is based on a categorization that if a package did not receive a release in the last 12 months, it could be considered abandoned. That is, pretty much how they found it out. And honestly speaking, you could argument that maybe a package has been mature, maybe a package made it to feature complete. Except, maybe the reality is a bit different. And 61%, more than half of packages on NPM, for example, that could have been considered abandoned, that's pretty high anyway, even if we could, consider some of these counter arguments. So let's see, what happened related to a package that could have been considered an abandoned package. We have the event stream incident. Event stream is a package maintained by Dominic Tarr, who is a member and friendly user of the open source community on npm JavaScript. And event stream has been a package that has been there since 2011, so almost a decade. It practically did not even receive any new releases in the last 2 years to this incident happening. By the way, this incident is not related to event stream as a malicious package itself, but rather another package, which was flatmap stream, which was malicious. But how did flatmap stream got and related into event stream? So suddenly, out of the blue, for this event stream package in open source project, being built on GitHub, suddenly a person shows up, right? And they offer to fix some issues, and they open issues themselves and add a new PR that fixes them and so on. And Dominic has a lot of other things that he's doing, 400, 500 other packages that he's maintaining. So this person coming in and offering to help with event stream that receives millions of downloads a week, this is actually pretty great. And this is the story of open source, isn't it? So that person continues to basically promote new more PRs and basically contribute more and more. And one of those contributions have been to add a package called flatmap stream for a specific functionality into event stream. So let's take out whatever code we wrote and put it into a reusable third-party package, and then add that into the dependency tree of event stream. Now, so far so good, except that person also controls this flatmap stream. So few weeks down the lines, that person actually adds a malicious code into flatmap stream that is doing something nasty for specific developers, which I'll get to in a second. But the moment that we are incrementing a version of flatmap stream, specific version ranges of event streams that would get installed will now pull in this new version of flatmap stream. So if prior versions have been reviewed, that's fine. But if that last version of the dependency of flatmap stream, which is now malicious, is not reviewed, that's a problem. And all of this is happening in the public eyes, right? This is public open source. Anyone could look at it, but we failed to find it as a community. We failed to find it, fast when it happened. Now, what exactly happened there? What is that malicious code that was in flatmap stream? So interestingly enough, the event stream incident as a whole was just a way to get into a different project. What happened is, that group, that person who had, orchestrated this entire thing for event stream had actually targeted developers building a Bitcoin wallet application from a company called Copay app. This is the app that they targeted. And because that application was, kind of like orchestrated and worked in the open, you could have seen which packages are being used by developers there and in which stage. Like, event stream was part of the build stage. So that malicious package, when it was installed, npm as a package manager allows packages to run scripts. So when it was installed, would have run any flatmap stream related code. And so all of that kind of trickles back in and forth. And what we have now is a malicious version of event stream, because it is pulling malicious versions of flatmap streams unknowingly, but knowingly to one person who orchestrated all of this. And this has been going on for 3 months until it was ended with 2 versions released by the Copay app that were including this malware to steal Bitcoin from wallet applications from users, basically, until we found it, which is, by the way, just because someone had raised an issue related to this thing, all of it happening. So, this is a story of a potentially abandoned package by that research that ended up really being and affecting, being malicious as the outcome of this, and really impacting all of us, millions of users who were impacted by this. So here is a mental exercise, right? By this point, you're building an application, could be a Java, Go application, Rust, whatever is your thing, maybe Node.js. And your mental image of this application is the following blob, right? It's this big blob where you're building this app and it does one thing or the other and so on. But really, the reality is a bit different. What we're actually building and writing our own code is a significantly smaller portion of that entire application code. So our mental image of our application is actually this composition of open source packages and code that we're using that is community powered and built by me, you, everyone else, basically, right? Everyone who are citizens on open source. And we're leveraging this. This is amazing, but we need to understand and keep an eye on this risk, because this is the reality of what's happening. Now, it's one thing to say, let's keep an eye on open source packages and understand the risks and track them. And it's a different thing doing so. Why? Well, it is hard to imagine building anything without open source dependencies, right? The thing is, dependencies use also more dependencies themselves. So, managing dependencies for a project is an important task, and it requires due diligence, and it's a hard task. But it is completely different in terms of managing a tree of dependencies that you get with some ecosystems. So what we're seeing here is this chart from the State of Open Source Security report that shows us for projects that were scanned with Snyk, what we could tell, in aggregate for users is if you look on, the right part of that chart, you could see some ecosystems like Maven, like Ruby Gems, like NPM, in which when we find security vulnerabilities when users scan their projects, we actually find them in indirect packages. So mostly these are packages that even you as a user are, as a consumer of building a project and consumer open source packages, you're not really in control of those packages, of those versions. There are maintainers of the direct dependencies that you add that are, in somewhat control of those, depending where they are on that tree. So you could see how really complicated this case of understanding where vulnerabilities come from, and of course mitigating this problem and finding, that least less of resistance route of finding, which one to upgrade and what if you can't upgrade, maybe you need to patch it. So all of this thing is part of what we should kind of consider. So moving on with other examples of malicious packages, what could possibly go wrong with indirect dependencies, right? Well, here's a timeline of security incidents that stemmed from malicious, attempts. Some of them were to backdoor projects, steal credentials, steal your API key, steal your token for NPM, still different things. We talked about event stream as one of them. But there was another one that is, it's really curious to take a peek and understand, what is the impact of malicious packages, because the fact that anyone could maybe submit tomorrow morning a malicious package into a repository like NPM, that's one thing. But getting that package into billions of users is another thing. So let's see what happens with one of them. Let's talk about the get cookies. A package was built, a couple of years back. You would think that this, is a package to help you basically work with cookie data in one way or the other, but maybe it's not, let's say. In fact, actually, it is nothing less than a command and control backdoor that has been built with the sole purpose of allowing anyone, remote attackers, to basically send and create remote code execution on any web server, any Node.js web server that is bundling this dependency and using it as a valid express middleware for their applications. Well, how does it do it? How does someone gain access? Well, if you have a route that is exposed over HTTP, what this backdoor does is it basically, as a middleware standing there and on the express middleware stack, it's basically able to look at any requests coming in, and based on HTTP headers, what it does is it parses the data that got sent to it, and then one of the commands that you could send is clear the data, make some room for more code to go in. Then load the code. The second request of the HTTP that you would be sending as a malicious actor here would be to run some JavaScript. That last command would be execute that piece of JavaScript that I just sent right into the buffer, loaded it there, just execute it, basically run evaluate it on the server side and run it and execute it on the Node.js web server. So this is what this command and control backdoor did. But the thing is, having one package is, who's gonna find get cookies. But having 3 packages is still who's gonna go and find HTTP fetch cookies or express cookies if they have 5 downloads or 20 downloads or maybe more. But it's still very less. Certainly on a repository or registry like NPM that has 1.5 million packages. Well, what can we do? So we find another package that we can compromise. We can basically create an account takeover, like Mail Parser. Mail Parser has 500,000 downloads a month. What if we were able to basically inject this dependency tree, one of those packages that is part of the tree, into Mail Parser? So when Mail Parser gets downloaded, all of those gets downloaded. So the next day, what happens is, hey, you are downloading or searching for get cookies packages, something that does cookie manipulation on Express, and you find this thing called Express cookies. And now it actually has 200,000 downloads in the last week or last month. Well, now maybe I'll use it. Now maybe I'll consider using it because I know there's a ton of users using it, or are there? So this is a real story. This is all happened. The maintainer of Mail Parser, account was compromised. And indeed, this incident, really did happen. So here's what we could learn from it. Now, we talked a lot about open source supply chain security, the risks from it, the concerns for maintainers, for us as users, all this impact. And, there are more and more stories, and this is going to impact us more and more years to come, because we're all using open source. And these are great stories. These are, really interesting stories of what is happening and what we could learn from them. But these are, the one-off stories, those malicious, packages, those malwares, and so on. Actually, regular vulnerabilities, those with a CVE, right? They happen all the times. Things like, the OWASP top 10 of, SQL injections and command injections and XSS and, server-side request forgery, all of those things, they're actually more common. We do find more, security bugs, if so to say, in open source packages all the time. This is growing as well. So, things like SQLize, if you're not, on the latest version, you are probably vulnerable to some SQL injections if you're using this ORM. If you're using something like Markdown to JSX, the fact that you are using as a developer React as a front-end framework, for example, is great. If you're using, all of the best practices, that's amazing. If you know not to use dangerously set inner HTML as, dangerous API, or if to use it, how to use it properly, this is amazing, incredible. But it doesn't mean that other maintainers, other libraries that you're using do not have those front-end related, security vulnerabilities related to XSS, for example, that could happen because of regressions, because of someone missing something, because of some rule, not being obeyed or something like that. So the fact that you're using a modern framework doesn't really, relate to anything else as well. So you need to be on top of those packages, even if you think you're following all of those, correct best practices for security. So we talked a lot about, Markdown and, other packages vulnerabilities, but really what I want to do in this kind of second half of this talk is really hack a live application. I want to show you how we get from vulnerabilities that we find in dependencies and talk about them for, this, 15 minutes or so, and take that into application vulnerabilities, into vulnerabilities that actually, stem from those vulnerable dependencies, but actually impact the application itself. So let's see how that works like. So what I'm going to do is I'm going to start up my server here. So Mongo, yeah, I need Mongo running. So we're going to have a node, backend here and a JavaScript front end. So it's going to be easy enough for us. So it's npm run start. And we should have a server running, waiting for an endpoint over here. There we go. So we have this, Goof to do application. And I'll zoom in a bit more. And what is it actually doing? Well, I can do, several things, right? Like, hi, Datadog, and things like that, hope you're enjoying the conference and whatever I want to add in my to-do here. So this is, nice and fun, but could I actually exploit this? What could I do from this point on? Well, what if I wanted to, well, this is user input, right? So what if I wanted to actually inject something? I could try something like script, the classic XSS, where we're trying to execute a script and persist it on this database, this application, server, service, whatever this product is, trying to persist it. So whatever someone else just, loads this page, maybe they would be affected and that script would be evaluated on the DOM as a valid JavaScript by the browser and executed. So we tried it, but it's not really working. Why is it not working, you're asking? Well, let's see. I've actually added another kind of small contribution to this to-do list, which is, well, what if we want to support Markdown like I was trying to do before, like things like hi like this, right? And we actually want to make things like bold and emphasize. So we could do this, and we could add links or underscore. We could use Markdown for it. Now I'm not going to go and create a Markdown parser myself all from nothing. So I will go to something else like npm.js or the Sneak Advisor, and I will look for Markdown related packages. So here I am going into this is the Sneak Advisor. I could go and find marked, which I know is a Markdown parser. I see it was published 18 days ago. It really has a good high health score. It looks like it's maintained, active, known security issues in the latest version. It gets downloaded 4 million times a week. That is a lot. So I'll go ahead and use it. This is great. I could go and see which packages, or sorry, which versions of this package are actually vulnerable, whether that's a high, medium, and whether that's direct, indirect, or maybe there are license issues. So interestingly enough, there was a direct high vulnerability for Markdown, just this past few weeks. So, let's move on with this. I did choose Markdown, Mark to do this Markdown, and this script tag didn't work. So why did it not work? Me looked into Marked, and oh, that's right. I now remember that when I used this, someone told me that I needed to do set options sanitize true, because this basically ensures that Marked will be running in kind of like this secure mode, where it will now sanitize any strings that I give it. So this is great for us. This is what I was hoping for, and that's why it didn't work. One thing to note here, though, Marked was in this version that I'm using, that I know has some security vulnerabilities that I want to show you here. It defaulted basically to a false here. So if I just use Marked, I did not know that I needed to enable this configuration option. I did, no one told me. I did not read the README, or if it was even on the README, I would basically be using Marked by default as a vulnerable, exploitable way, and that script alert here would have worked. So thank God I've got this protection in. So that's good. What I could do with Markdown is things like this, right? I could add an address for a website and create this sort of links. This is great. This is why Markdown is really helpful and nice. What if I wanted to use the same route of basically creating an injection attack vector here into the application? Maybe I wanted to do something like JavaScript alert over here, because that's something that I could put in like an href if I'd be doing plain old anchor tags in an HTML element. So I could try doing this. Let's see if this works. Not much. It's breaking down, and the fact that it is not really working too well is due to the fact that that sanitization piece that I've added here is quite smart. It's quite useful. What it does is it actually has a regular expression that looks for something like JavaScript : and when it finds it, try to sanitize all of this junk kind of like away from the string, because it understands this could be malicious. So what could we do at this point? Well, I could go and look at Marked source code, because this is open source. Just go to the repository and see how the regex works. Maybe I could find, some way that I could bypass the regex. Well, one way is going to be, even without looking at the code, is I could go ahead and try to, I could go ahead and try to basically represent colon in a different way, maybe in the semantic way of HTML entities. So HTML entities are basically, strings or characters that allow us to define certain elements on the screen without using the actual element. What I mean by that is I don't need to do colon. I could actually go and do this HTML entity that represents colon. And when the browser sees this, the browser says, well, I think you meant colon, and it will actually replace it to what it is, and then display a colon without actually parsing or evaluating colon as an actual JavaScript or HTML related context. So I could do something like that, and I know I probably need to close this one for this to work. So maybe I'll try this HTML entity, which I know is the closing tag. So let's try this and see what happens. Well, I know I was also hoping for this to work, but it didn't. At this point, what really happened behind the scenes and in Marked source code is, that sanitized piece of true, instantiating it like that, was actually pretty smart. The maintainer here was very conscious of what we would be trying to do, and based on that, they have also have a regex that looks for HTML entities, because they know this is encoding characters is like a really good way to kind of like escape what you would mean, and the browser might be exploited due to this. So there's a regex that actually detects this and pushes all of our bad malware here away. So what I could try instead is, how about if I try adding something into here, like the word this, like literally this word. what happens at this point is the regex looking at this, well, doesn't recognize, that part of the string as a valid HTML entity, and rightfully so, because this is not valid anything. So the regex fails and marked, bypasses, and this is just fine. But a browser receiving this is understanding that we wanted to add an HTML entity, but we're missing a semicolon. But the browser, it will help us out, and will close this for us. And then the rest of this becomes just fine as a valid, JavaScript and element into the screen. So basically, if I try this attack vector, which maybe as a small task would have been, kind of like an unintended behavior. Let's see what happens now. Well, look at that. I have a cross-site scripting vulnerability here. So I am using an open source package called Marked, which I did use as sanitized true, which has some protection from script tags and all of those other things that could be malicious. But it has a very well-known cross-site scripting vulnerability, which is this. This is a different one that it's not really escaping and doing correctly. So this is the payload. But it's an interesting story of open source to understand like what really happened here and how did we get to this point. So if I scan my application this is the Goof app, by the way. If you want to go to like the GitHub/Sneak/Goof, you will be able to like use this app yourself and train and learn from it. We have a bunch of exploits and readmes that you could work through, and you could scan it. You could just add a project, GitHub or wherever you're taking it from, and see the package manifest or Docker file, or we'll do static analysis when that is generally available for everyone. And when that goes out, I could go in to my package JSON and see what it actually found and what happened there. So let's try and search for marked. There's a ton of dependencies here, and I could look at the dependency tree and find what is going on. So I see marked with several issues, high and medium and so on. But let's look at the vulnerability cards themselves and see what's going on there. So this is what I just showed you. This is the exact POC, which you could see we have provided you as a user to see what is really wrong with this vulnerability. So there's a score, there's a CVSS one here. This one is a little like priority score for you to basically fix it. Why should you fix it? Hey, there's a fix available in all of those things. There's an exploit and so on and so on. We're saying, which vulnerable function is it that actually impacts this vulnerability? This is also really helpful if you're using something like Lodash, which is really big generic utility package, and maybe it has a prototype pollution, but maybe you're not using the affected and vulnerable version. So you could actually have more information to triage what is going on. Of course, if there's a fix, you always want to be on the latest version, which has no known vulnerabilities for. So always upgrade. Makes sense if that's a really quick way for you to mitigate a problem. But anyway, we have more information here, like looking at, well, what is going on with this, right? Like, what is this POC? So I want to show you what was going on. What is the story behind this vulnerability? And this is really the story of open source. So this is the vulnerability page on Snake with the 6SS. We see which versions are affected. It was discovered by Matt Austin, a security researcher who helped uncover this. And there's a bunch of information of how this works. And you see we have like patches if you couldn't upgrade, which we'll see why this is so important. Well, what if I can't upgrade Mark to 036? Let's take a look at the GitHub PR now in retrospective. This happened a few years back, and we can see what was going on there. So Matt opened this issue and pull request back in 2015, right? Opened this back in 2015, May 20. All of the information is here available for everyone. People are thumbs up. This is great. The pull request is great, right? This is a fix, not just complaining of an issue of an XSS with this library, but also fixing it. Also adding some regression tests, that shows us how to replicate it and, make sure that it doesn't replicate again or reproduce as a regression in the future. So this is great, except the time that this was actually landed and going into an actual release that you could upgrade to was about a year later. Now, this is a year where all of those millions of users who downloaded Marked were basically vulnerable to this due to like a publicly known vulnerability. This was out in the open. So it is it is something to think about, right? The fact that we might be vulnerable to this kind of dilemmas where we're using open source and we are dependent on others to fix the issue. So luckily, Fix has this patches which you could apply, very quickly without with a sneak tooling and without an actual release. But still, this is a story of open source. So back to where we were, right? UpSec is challenging, right? Up security is challenging because software delivery is just spitting up. We need to be on the edge all the time. Attacker just needs one way to get in. We need to close up all of those possible ways for them to get in. Also because there's no like formal education for application security in a sense, right? This is a slide from one of the recent DEF CON conferences where someone was putting this out and said, these are the top 10 US computer science programs. Which one do you think has a mandatory class to enroll to that involves InfoSec or AppSec that you have to take to finish your to get your degree? Well, you could think, which one of those is more likely to basically have that as a mandatory requirement? The reality, none of them to that point in time, right? Because we are not really teaching students how to graduate and be very security experts and expertise and have those skills. Like we're missing on other things, maybe we're not teaching them accessibility related things and performance, all of those cross-cutting concerns which are important, but we are missing out. And that's why we may end up with those security bugs in the code. And that's why this is important, that we are actually practicing secure coding practices and conventions, like some of these cheat sheets that we're writing and advocating for at Snyk, helping you basically follow what you should probably do as a best practice. And so are maintainers, right? The open source packages that we use. So with that said, thank you for joining my talk. Use open source, it's awesome, but please enjoy it responsibly. Thank you very much.